Hello scientific people, how are you today? So today I'm going to discuss about micrometer screw gauge, and we will be deriving the formula for micrometer screw gauge measurement, and I guarantee you that this will be no mug up session. You will understand everything. So let's start with the parts of the micrometer screw gauge. So these are 6 important parts of the micrometer screw gauge. This part is called the circular scale. As you can see that I can move this circular scale. It is also called as thimble, and there are some markings which are done on the circular scale. So I am zooming it so that you can see it in a better way. As you can see that the circular scale is being marked with the readings. So here 0, then 10, 20, 30, 40, 50, 60, 70, 80, 90, and again back to 0, that is 100. So there are 100 divisions, and there are some screw gauges in which you may find 0 to 50 divisions on circular scale as well. So these are called the circular scale readings, and then if you turn it or if you rotate it like this, you can see that more and more readings on the main scale. This is the main scale, and this is also called sleeve. So if I turn this in this direction, you can see that the main scale, we can see the readings appearing on the main scale, and this is the main scale which is also called the sleeve, and these all readings are in millimeters. So this is 0 mm, 5 mm, 10 mm, then 15 mm, 20 mm, and last division would be, or the last reading on the main scale would be 25. And it is because this is the U-shaped frame. As you can see that I have already mentioned it over here. This is the U-shaped frame, and in U-shaped frame it is already given 25 into 1 mm. That means 25 mm can be the maximum length or thickness that can be measured with the help of this particular instrument. Now ratchet. So ratchet is very important part, people. Suppose if let's discuss first about the awl. So this part is awl, this is awl, and this is spindle. And as you can see that if I move this circular scale, the length of the spindle decreases in this direction, and if I turn it in this way, the length of the spindle increases. The awl is actually having the screw at the back side to fix the errors, and I will take a separate session in order to explain you the concept of errors. So let me first of all fix this pencil over here, and I am going to move this, and I better ask all my viewers not to turn from here. It's better you turn it from here, and you will hear a sound. That means this is very rigidly fixed between anvil and the spindle, so you need not to do more of the don't make it more tight. So if the ratchet makes this kind of sound, that means it is to be understood that this object or this pencil is rigidly fixed between the anvil and the spindle. So these are the basic parts. This is called ratchet. So hopefully you have understood the use of the ratchet as well. Now what am I going to do is, I am going to zoom in, and I will explain it to you some important terms like least count and the pitch. So let's try to understand this by the greater resolution. Okay, so as you can see, people, that this is the main scale, and the main scale readings are in mm. So this is 0 mm, then 1 mm, 2 mm, 3 mm, 4 mm, and 5 mm. So the distance between any two consecutive divisions is called pitch. So that means the distance between any two divisions on the main scale would be 1 mm, because this is 0 mm, then 5 mm, then again 1 mm, 2 mm, 3 mm, 4 mm. So the distance between two consecutive readings on the main scale is called pitch. And you would be also amazed to see one thing. Let us take one short observation from here. Now this line is called the baseline, people. This horizontal line is baseline, and let me match it to 0 of the circular scale. So right now the 0 of the circular scale and the baseline are matching. Now I am going to turn it by 100 divisions, and you will see that the circular scale moves by 1 mm to right. See, I am 10, 20, 30, 40, 50, 60, 70, 80, 90, again back to 0, and you have seen that this circular scale has traveled a distance towards right hand side by 1 millimeter distance, which is very important for us, people. Once again, as you can see that after 10, 11, 12 and 13 mm you can see over here. Now again I am going to turn it by 100 divisions, and you will be seeing the 14th one as well, the 4th division here. Very important property, people. So if you move the circular scale in this direction, like if you turn it downwards by 100 divisions, this circular scale will travel a distance of 1 mm. Very important. If I rotate in this way, again the circular scale would travel 1 mm distance, but now in this direction. So hopefully you have understood the pitch. Pitch means the distance traveled by the circular scale, one complete rotation. The linear distance traveled by the circular scale after one complete rotation, or it is also the distance between two consecutive divisions on main scale. So now let's learn about the least count, people. Least count is equal to pitch upon number of divisions on the circular scale. So as you can see that this has got 0, then 10, 20, 30, 40, 50, 60, 70, 80, 90, again back to 0. That means 100 divisions on the circular scale. And as I explained you that pitch is the distance between two consecutive divisions on the main scale, and as you can see that this entire scale is in mm, so any two divisions, the distance between them is 1 mm. So 0 mm, 1 mm, 2 mm, so distance between any two divisions is 1 mm. So now let's do some mathematics, people, and it's very easy. So pitch is equal to main scale, that is 1 mm, divided by 100 divisions on the main scale, that is 0.01 mm. If I convert that into centimeter, I will have to divide this by 10, so 0.001 centimeter, that is the pitch. Pitch may vary from screw gauge to screw gauge. Had it been 50 divisions, here I have a screw gauge with 100 divisions. Had it been 50, then I'll have to put 50 over here and the least count will be different, right? Okay. Now least count is the least distance that can be measured. So let's try to understand that in depth. Okay, people, now after learning the concept of least count, let us look at the formula that the textbooks say. The textbooks say that the total reading is equal to main scale reading plus the number of division that is matching, coinciding, multiplied by the least count. But I always believe in deriving the things and understanding the things. So that's what I am going to show you over here. See, now we know that if the circular scale is suppose on 7th division, 7 mm, and if I move it by 100 divisions, this will come over here and it will travel a distance by 1 mm. If circular scale, which was already on 7 mm, if you rotate it by 100 divisions, then the circular scale will travel a distance of 1 mm. Let's see this. Now again coming back to the derivation, people. See, suppose the circular scale is over here. Suppose you put a You put some object over here like this and you close it with the ratchet, and suppose this is your circular scale and then the circular scale is over here. That means the length or the thickness of this particular object will be 0, 5, 6 and 7 mm, but greater than 7 mm but less than 8 mm. So we are going to find out, and suppose here nth division is matching of the circular scale, it can be between 0 to 100 with our baseline, correct? So I am going to just enlarge this diagram over here. It is clearly visible, people, that the length is 7 mm. So my total reading would be equal to 7 mm plus some extra reading, that is this distance. Let me call this as x, right? But since we have already seen that if you move circular scale by 100 divisions, then it travels at linear distance of 1 mm. So if you turn it by 100 n divisions instead of 100 divisions, see, this can be 20, 30, 40, 50, any reading. So if you turn the circular scale by 100 divisions, this circular scale will come from here to here for sure, that you already seen. But if this circular scale turns by n divisions, and that n is suppose 40 divisions, then this distance can be calculated as under just by cross multiplication. For 100 divisions, if it travels by 1 mm, then for n divisions or 40 divisions, it will travel by x distance. Now cross multiply, so it is equal to x multiplied by 100, that is equal to 1 mm into n, right? And then this x is equal to 1 mm upon 100 into n. So this is the value that I am going to substitute it over here. This is our main scale, people, main scale reading, MSR. So I am going to write this as MSR plus 1 mm upon 100 into n. This is least count. So you have derived the formula actually. See, main scale plus least count into n. This is what our formula was, correct? So what is the main idea? Main idea is if you are over here, then not at all an issue, because this circular scale, if it is over here, then definitely the 0 will be matching over here. 0 of the circular scale will match the baseline. And if this is over here, then again not at all an issue, because again the 0 will fall on this particular division, that is the 8th division. But if you are somewhere over here in between, then this will certainly never be 0, it will be some 40, 50. So what we are making use of the maths is, if this circular scale moves by 100 division, then it travels a linear distance of 1 meter, 1 mm. If it travels suppose by 40 divisions, then this x is what we are supposed to add it in 7 mm. So my total answer is 7 mm plus x. This x can be calculated by cross multiplication. Now let's have some demonstrations to understand it. So people, now let's apply the concepts that we have learned in practice. And here is our micrometer screw gauge. Its least count is 0.01 mm. And I wish to measure the thickness of my eraser with the help of the micrometer screw gauge. So I am going to put this eraser in between. Then I am going to turn this with the ratchet. Okay, now since you have heard this sound, that means we are supposed to stop. So now what am I going to do is, I am going to take the readings. Let me show you with greater resolution that over here, as you can see that this is our main scale. This is 5 mm, then 6 mm, 7 mm, 8 mm, 9 mm. I can see 9 mm reading over here, but there is some more extra distance that this circular scale has travelled. That means my answer, the thickness is between 9 mm and 10 mm. But people, as we cannot see what is that distance, so we are going to use the mathematics. We are going to apply the formula and we are going to logically understand that, and let's find it out what is that, right? Okay. Now as you can see with a greater resolution that ninth division that is 9 mm on the main scale is being seen, and then this is 90. So as you can see this is 0, then 2 division less, so 98th division, actually it is 99th division that is matching with the baseline. So this is our baseline and 99th division is matching, correct? So on circular scale reading I have 99 divisions and on main scale I have 9 mm. So let me note it down. Main scale reading is people 9 mm, circular scale reading is 99 division. Now there is no need of mug up, as I said. You can use maths also, you can use direct formula, and you can also understand this, correct? I know what is the least count, that is 0.01 mm. So I am going to apply the formula as total reading is equal to main scale, that is 9 mm, plus circular scale division, that is 99, multiplied by the least count, that is 0.01 mm. So this is going to be 9 mm plus 0.99 mm. So this, my answer will be 9.99 mm. This is my answer. Now people, as I have already told you, there is no need to mug up, correct? If you don't remember the formula, just use simple mathematics. We know that if we move 100 divisions on circular scale, the circular scale travels by 1 mm distance. So here we moved circular scale by 99 divisions, so it will be traveling by some extra distance, and that distance will be the product of these two, correct? Let's call that distance as x. So this extra distance that the screw gauge circular scale is traveling shall be equal to x is equal to 99 into 1 mm divided by this, multiplied by this, divided by 100. So my answer is going to be 0.99 mm, correct? There is no need to mug up, people. As I said that if the circular scale moves by 100 divisions, then it travels a distance of 1 mm. Then if the circular scale travels by 99 divisions, then the distance travelled would be equal to 0.99 meter. Now let me tell you that already 9, this is 5, this is 0, this is 6, 7, 8, 9 mm. It was clearly visible, but now the circular scale was somewhere over here. So we had to find this extra distance x, which this circular scale moved by 99 divisions. Had it been 100 divisions, no need to measure, then it would be on the 10th division. So now it is clearly visible that the distance is 9 mm plus the extra distance that the circular scale moves when it travels by 99 divisions. So I have to add x, so 9 mm plus this x is I have calculated logically, that is 0.99 mm. So my answer is 9.99 mm. So you don't have to actually mug up the formula, people. Just remember, you are supposed to convert these circular scale divisions reading into linear scale, right? This is one example, and I am coming back to the practical part. Now I wish to find the thickness of the pencil. So I am going to fix the pencil between the spindle and the anvil, and the ratchet has already given me the indication that it is straight. Now let me show you, people, that with a greater resolution, you are looking at total 5, then 6 and 7 divisions. So already 7 mm distance is visible on the main scale. So that means the length of the pencil is more than 7 meters, because as you can see that this 0 is not matching with the baseline. Had it been 0 matching over here, you could be exactly on 7 or 8. So that means the length of the thickness of my pencil is greater than 7 mm and it is less than 8 mm. So this extra distance that circular scale has travelled apart from this 7th division 7 mm is what is needed to be found out. Now let me see that which division is matching. So this is 90, this is 95, 96, 97th division. So it's very hard to see people, but I can make out that this is 97th division which is matching with the baseline. So 97th division on the circular scale is matching with the baseline. So let me take down the readings. So that means main scale was 7 mm, correct? Let me do it in two different ways so that you need not to mug it up. Circular scale reading was 97 mm, 97 division. Least count was 0.01 mm. So if I apply the formula, main scale, that is 7 mm plus 97 number of division matching multiplied by the least count. In this way, this is 7 mm plus 0.97 mm, that is 7.97 mm is the thickness of the pencil. Now as I said, you need not to mug up people. See, as I told you that this is 0 mm, this is 5 mm, then 6 and 7. So already 7 mm length is visible. So 7 mm for sure is the length, plus this is suppose 8 mm and this circular scale was somewhere over here. So this extra distance x is what we are supposed to measure. Now this is the 97th division. So I am going to use mathematics. I know that if this circular scale moves by 100 division from 7, it would reach 8. That means it will travel 1 mm distance. So if it moves by 100 divisions, it will travel a distance of 1 mm. Now it has actually traveled a distance of 97 divisions. So how much distance it will travel? X. From here to here, it has traveled x distance by 97 divisions. Cross multiply. So x would be equal to 97 upon 100 into 1 mm. This is 0.97 mm. This is what I am going to add over here because my final answer is this. This is clearly visible and this I have calculated logically. So 0.97 mm. So my answer logically is 7.97 mm. So I always ask my viewer not to mug up the formulas. These are just for piece of remembering, but you have to actually remember in this way. So what we are doing is we are converting the circular scale divisions into the linear distance.